Hey everybody, it's Walt here from OverKill Projects. I came down to my dumpster area at my apartment complex here to toss away some cans, some really exciting stuff. And I had a serious like Dave Jones EEV blog moment. I opened the door and what do I see but boom! There are two massive TVs here that somebody threw out and was kind enough to protect them with a mattress too. So I'm not going to take that guy back there. It's got to be like a 60-inch Mitsubishi. It's like one of those like maybe last or second to last generation projection TVs. Probably weighs, I don't know, more than my car. So I'm just gonna leave that down here. But this guy, it looks like it's in pretty good shape actually. So I am going to take a quick peek at it here and then run it up to my apartment. I was gonna go to the store and get some lunch, but it looks like we're putting that off for a minute. I don't know, I'm gonna get all sweaty. But okay, let's do this. I'll meet you up there. Oh my god. Alright everybody. I got it up here. And I'll switch to the real camera in a minute. It's still on my cell phone. But oh my god, getting that up here was a nightmare. Without a dolly. I'm seriously. I was gonna go to the store, but I'm gonna have to change my shirt now. Oh, that was killer, but look at this thing, it's huge. I think that what's wrong, and you're almost certainly not gonna be able to see this on camera. Maybe you can see that. And I'll try to get a better shot in a minute, but it looks like we have a damaged panel there. And that maybe it's got a crack on one of the layers, or maybe something's peeling away. I doubt that I know how to repair that, but we'll still break it open and take a look. I'm sure that there's all sorts of fun stuff inside here to peek. Hey, and there you go. You can see the rest of my apartment. The angle that I haven't shown you yet in my like one video. So, all right, let me go get the other camera, change my shirt. Actually, I'm gonna go get some lunch, and then I'll be right back. We can start tearing it apart. Let's do it. Sorry for one more interruption, but I'm here at the store. And today is my lucky day. Not only do I find a massive TV, but what? Crab Fest at the Wegmans? Life is amazing. Oh, look at those cracks. Oh my god, here, I'm gonna get up close so we can actually see that a little bit. Yeah, look at that. It's like a piece of artwork, I gotta be honest. I kinda wanna put it on the wall. That's amazing. That's really a shame, isn't it? It's amazing when the TV's off and the backlight's not lit, you really cannot see any of that. All right, let me go grab the screwdriver. We're gonna put this down. And I'll take the back panel off. We can kind of take a look and see what's going on inside. There's nothing in here. Who else finds this more than a little bit disappointing? There's a power supply board, what looks to be a peripherals board with maybe some sort of custom ASIC, and a panel driver board, and that's about it. I am going to go ahead and take these off, and we can look at them one at a time, but there is very little here to actually examine, so that's okay. We'll take a look anyway and sort of see what's going on. Over here we just have the power supply board. We'll take a peek at these individually in a second and sort of ogle some of the parts, but it's all pretty straightforward really, right? So this is just the power board, and so now then this is going to be the it's like the accessories and peripherals control board. It takes in, so this is going to have
decoders and all sorts of stuff for your HDMI, USB. Here's your your cable in, all that sort of stuff, RCA network. And then it's going to take that data and translate it appropriately, send it out and down to this card down here, which is actually facing this way in the television. And it has a little controller that's just going to be the panel controller. So this is going to take, the signal that comes in that says what it should display. It's going to say, okay, we'll display that, and then send the appropriate signals out to the panel itself. So, okay, so that's about it, but let's take a look at what's actually on the boards themselves. I'm just going to switch to my macro lens so we can get a little bit closer to the board and see what the actual components are. Let's take a look.
Here we have a pretty classic filtering and input stage for a power supply. We have a MOV or a metal oxide varistor, as well as some pretty beefy common mode chokes, and some class X and Y capacitors. And basically all of this just serves to filter out any sort of noise or transients or voltage spikes that might come in, as well as protect the device in the case of there being some sort of short or something like that. And looking at the other side of the board here, we actually see that they went an extra step and have sort of a last ditch mode of protection here. There's 4 spark gaps you can see here. They're just to stop any sort of like super high power surges that might come through and otherwise fry everything on this board. Here we have the full wave bridge rectifier, which you can see they use 2 3 amp diodes in parallel for each branch of the rectifier. So this has a maximum continuous current of about 6 amps, which seems right for the electronics that they actually have on there. My guess is that most of that power is used to drive the CCFL backlighting panel, and that only a small portion of that power is going to be used to do the actual processing, which you can kind of tell because there's only one heatsink on these boards and it's not all that big. And before we go on, you see these 3 capacitors here that we have in parallel. You can see they're pretty beefy, right? They're 450 volts each, 82 microfarad. These are not smoothing capacitors like you might normally see after a rectification stage. Instead, these are actually going to hold our regulated power or our regulated voltage from the switching regulators that we're going to look at in a second. And you can see, I mean, they're rated for 450 volts. So something I should point out here is before I did anything in here, I discharged these capacitors so that I wouldn't, burn the hell out of my hand. And you should really be doing the same. Don't go poking around inside, a power supply board or any sort of power electronics, really anything, without taking a look first to see if there's not something that might be storing electricity that's gonna zap you. After the rectification stage here, you can see we have some pretty beefy components, a couple really large inductors, some diodes, pretty beefy diodes, and then there's a few switching transistors, a few MOSFETs that you can see screwed down here underneath this heatsink. The 2 bottom ones and the inductors here are going to be used for one switching regulator, and the other one that's towards the top there is going to be used for a separate switching regulator. And here on the underside of the board, we can actually see both switching regulators. The top one, the little one, is just going to be used to output 12 volts, and that's going to be used for all the like for the processor that's on the board and the peripherals and all that sort of stuff. But then this bigger guy down here is pretty interesting. It is an ON semiconductor. It's FAN9611. It's a pretty beefy switching regulator. It actually switches our voltage up to 400 volts, which is why you saw there were 3 450 volt caps in parallel on the other side of the board. They need to be rated that high because this will output about 400 volts that's going to be used for a regulator that's actually in a different zone of the board that we'll see in a moment. But something notable about this IC is actually its datasheet. Its datasheet is very involved. It covers a lot of the theory of how it works, and the application notes are very complete. So if you're all interested in power electronics, I highly recommend checking it out. I'm going to link it in down below. Yeah, so give that a once over.
And up here we can actually see that there's another zone on this board. You can see the dark line that delineates the two different areas of the board. This top area here is electronically isolated from the bottom area. You can see there's a couple of optocouplers, some transformers, and those are the parts that are going to actually carry our voltage over to this new zone. And so now the stuff over on the left here is carrying the 12 volts from the small switching regulator. So we have 3 parallel 16 volt caps here. They're just going to smooth out the regulated voltage out of the switching regulator, and then to really make sure that there's no noise, you can see that there's a little coil inductor up here right before we go into the 12 volt connector that's going to run over to our interface mixer peripheral board thing that we're going to take a look at in a minute. And over here on the right, we see the rest of the components that are going to be needed for our high voltage power supply. And the reason we have such a high voltage supply over here is actually going to be to drive our backlight. So I don't know if you know how a TV like this works, but there's actually an image panel that sits sort of in the front, and behind that there's going to be a backlight panel that consists of some sort of lighting element. And in this case, the television actually has a cold cathode fluorescent lamp back panel, and those just require a much higher voltage than you're going to get out of your main. So it needs that 400 volts, and there's another switching supply underneath the board that again is going to regulate, but now this time instead of so much regulating the voltage, it'll regulate the current needed for the CCFL. And then we can see that 400 volt supply actually runs out of these 2 connectors up at the top that'll go to each of 2 different backlight panels. One will be lighting the left side of the TV, and the other will be lighting the right side of the TV. And it's probably at least somewhat notable that the connectors are relatively small for connectors that are going to be carrying such a high amount of voltage. And that shows you just how little current is actually going to be required out of that side of the supply. All right, that about does it for our power supply board. So let's take a look at the sort of mixer interface board and see what's going on that board. Here we have what I suppose is the main processing board, and also sort of like the mixing board and peripheral board, however you want to think of it, for the entire television. You can see that under the heatsink there was an ARM processor. I honestly have no idea who this manufacturer is. A quick check online turned up nothing but a couple of Chinese reseller sites that claim to have this chip just sitting around loose. So if anybody knows, feel free to leave it below. I'm curious. And since the only other chip on the television really of any note at all is on the next board that we're going to look at, and does not carry any sort of heatsink or anything like that, pretty much leads me to believe that all of the major work is being done by this chip. And honestly, other than this chip, there's really not a whole lot going on this board. As we move around, you'll see a handful of switch mode power supplies. They're just going to be there to supply the appropriate power to the different peripherals. And we can also see that there are a handful of other ICs, but these are just a couple of DDR memory chips on one side of the processor, and a flash ROM on the other side. This thing has pretty much all of the standard peripherals, all the standard inputs that you would expect to see on a new television. We have 3 HDMI inputs. There's also one of them carries, it says on the TV ARC, which is an audio return channel, I believe. So that enables some sort of bidirectional communication with, I guess, a sound bar or a receiver or something like that. We have a USB port. There's optical audio cable, standard AV RCA cables, and an RJ45. But other than that, there's not too much going on. There are a couple unpopulated spots, but they don't look like anything above and beyond the norm. We can see that there's an empty spot for what appears to be another USB connector and 2 more AV inputs. I'm guessing a different sound channel, different audio channel. You can see that there's actually a spot for an amplifier. It looks like a differential amplifier just on the other side of those 2 unpopulated inputs. You can also see the clock crystal, which is 24 megahertz.
And I'm sure that there's a PLL multiplier inside this chip so that it's running faster than that. But it's interesting that really that's all there is going on this board. And then from there, it all heads back out either to communicate with the wireless chip, the wireless module that was on the other side of the TV, or with the other board that we're going to take a look at in a minute, which I think is just the image panel driver for the TV. And just real quick before we head over to take a look at that other board, you can see here the ribbon cable connector that goes out, and then the power connector, the connector for the wireless. We can also see a handful of switch mode power supplies here for the various peripherals, as well as in the corner there an audio amplifier. And of course, that's just going to be used to drive the speakers, which are actually connected to the other connector in the corner of this board. And here we have maybe the most and least interesting board to me in this whole configuration here. This is pretty clearly going to be the panel driver board. So this is actually going to create the signal that then will go out, and you see the two ribbon cable outputs on the bottom. They're going to send out a signal that will, one at a time, draw the pixels on the screen. And obviously it does that extremely quickly so that you don't even see it happening. In this case, you see there's two of these ribbon controllers, which tells you that the image panel is split up into two zones. And if you had looked at the back of the TV when I had it open, you would see that those two ribbon cables had gone into two long circuit boards that were really narrow. I didn't bother taking them out, but they run the width of the TV and connect to those two different panels. Under there, they'll just be soldered to the actual panels. But for all that, there's really not very much going on this board, right? There's two different power zones we can see here. Or three, I guess. There's at least two switching controllers, and it looks like a third smaller one. Although I don't immediately see any labels telling us what the output voltages actually are for those different channels. You can see that there's an awful lot of plain stitching on this board, and that's because the signals coming into and really out of this board are probably extremely fast, and they need the ground plane and any other power planes really to be as stable as humanly possible, because any sort of noise on these lines is going to create problems. But other than that, there's really nothing at all on this board. There's nothing on the back, and there's really nothing else to look at here because I don't have a data sheet for this controller, nor can I find one, and I'm guessing that you won't find one since this is probably still a part that's in use today. They're not going to give up a bunch of trade secrets by telling you, although it is a Samsung. It is a Samsung, why can't I say that? Samsung chipset in this TCL TV. I think I remember reading somewhere ages ago that TCL uses the same panels as Samsung or something like that. So I don't really know what their deal is, but yeah, so there you go. Samsung controller driving your panels. So, all right, there you go. The insides of a 65-inch television. I still have its carcass on my floor. That'll give me something to do later or tomorrow. Let's be honest. It's going to happen tomorrow. But yeah, that was super fun. If you enjoyed, make sure you thumbs up. If you want to see what we have in store, there's like another teardown coming. I have a couple little features that I'm trying to figure out how to shoot. I'm still new to this, but if you're interested in checking all that out, make sure you hit subscribe down below, get the alerts, comment if there's anything you want to see. And now I am going to go finish making my dinner. It's funny, when we started this, I was just getting my lunch together. So yeah, you spent the whole day with me. That pretty much killed a Saturday. Thanks for joining me. See you next time.